Alright, folks. Our CBA is scheduled for a week from, no, 2 weeks from today. It's not next Tuesday, but the following Tuesday. It is probably going to be a 2-day test, so it'll go over Tuesday and Wednesday. And it is over the entire semester. I did get a blueprint of what's going to be on it that I'll share with you next time. There are some things we still have to learn. This is questions that were on the CBA last year, so you have got to make sure you're paying attention to warm-ups. This is pretty much the only review you're going to get, because we'll be learning new stuff all the way up to CBA time. Alright, number 1, to square a binomial, you have to use FOIL to do that. You should have gotten a squared minus 2ab plus b squared. Oopsie. Alright, number 2 is just a plain old equation. Distribute the negative 5, distribute the negative sign over here, solve the equation like normal. I believe the answer was negative 1. Now, number 3 is a great example of how they take something that is simple and make it look scary, and kids freak out when they see it. This is raising a power to a power. What do you do with the exponents when you raise a power to a power? You multiply them. So you would do, the base stays 8, and these get multiplied. 2 over 3 times 1 over 2 is 2 over 6, which reduces to 1/3. Because the base is an 8. I mean, you have to have a base to have an exponent. So what they're testing here is that you know how to raise a power to a power, and they're also testing that you know how to deal with fractions. Now, what does this really mean? I don't know that they're going to make you work this out, but if they did, I will give you a calculator on test day, and you can actually raise 8 to the 1/3 power. Now, what that really means is you're finding the cubic root of 8. Basically, that means what number times itself 3 times is 8. Do y'all know what it would be? What number times itself 3 times is 8? 2. 2 times 2 is 4. 4 times 2 is 8. So you could do 8 to the 1/3 power, and the calculator will answer it for you. Now, what the calculator won't do is it won't know that you're supposed to multiply exponents when you're raising a power to a power. So you'd have to do this part by yourself. Does that make sense? Alright, inequalities. I'm betting there'll be at least one of those. When you divide by a negative, you got to flip the symbol, and you did have to divide by a negative here. I believe the answer was x is less than negative 9 over 2, or negative 4.5. If there was anything on here you don't get, this would be the time to ask. There will be a lot of multiple choice, yes. Number 4. Okay. I've got to distribute the negative 3 over there on the right, so I've got negative 5x minus 3 is greater than negative 3x plus 6, right? I always move my letters to the left. So I'm going to add 3x to both sides. So what's negative 5x and positive 3x? Minus 3 is greater than 6. I can tell right now I'm going to have to flip the symbol, because I've got a negative number connected to x. Only when you divide by a negative, but I can just kind of see what's coming. Now I'm going to add 3 to both sides, so I end up with negative 2x is greater than 9. And here's where the symbol gets flipped, because I am about to divide by negative 2. Only when you multiply or divide by something negative, that's when the symbol has to flip. And if the fraction's negative, they're usually going to put it at the top, not the bottom. And that's negative 4.5 or negative 4.5. Alright, anything else? Alright, I'm going to go ahead and do the lesson, and then we'll grade homework at the end. We are still looking at quadratic formula. I still want you to solve these using quadratic formula. And I am betting, if you're honest, that the more you did this last night on your homework, the easier it got. Good. Alright, here's the quadratic formula. Now, last night's problems, guys, focus. Last night's problems were rigged for you to where you got a nice perfect square inside the radical symbol. Tonight, that's not always going to be the case. It might happen that you get a nice perfect square and then you would do them just like you did last night. You'd keep on solving it. But if it's not, there's several different possibilities that could happen. And actually, it's really going to make your life easier, because if it's not a perfect square, I'm going to let you just stop. So let me show you some examples of what you're going to see. You might get a problem like this. I'm just making these numbers up. 4 plus or minus the square root of 20 divided by 2. What's different about that than last night? 20 is not a perfect square. Does that mean that this doesn't have answers? It absolutely has answers, but they're not nice whole number answers. 20 does have a square root, but it's not a nice whole number. Look what happens when I find the square root of 20. 4.47213 blah 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 blah. So does 20 have a square root? Yes. Is it a nice number? No. Now, this also keeps on going. The calculator ran out of space, so it just stopped writing numbers. So it is not a fun number to work with. So guess what? If that happens, that's your answer. You can just stop right there. I can't make you give me an estimate unless I give you a calculator. But you're not going to have a calculator tonight. So if this happens, you can just stop. Okay, well there is an estimated answer. Some kids don't like leaving it like this, but this is actually the two exact answers. One of them is 4 plus the square root of 20 divided by 2, and one of them is 4 minus the square root of 20 divided by 2. And I'll even let you just leave it all in one. You don't have to write it twice. And if you had a calculator, yes, you could find an estimate for that. I'm going to put the numerator all in one. I'm going to put this all in one line of work. So if it's a fraction, I got to put the numerator in parentheses. So one of them would be 4 plus the square root of 20, close parentheses, divided by 2. That's going to be about 4.2-ish. And then I'd have to do the same thing except replace that plus with a minus. But I'm not going to make you do this part because we don't have our calculators passed out yet. Are you with me? So actually, that kind of makes your answer easier. The other answer would be somewhere around 1.7-ish. But if you don't get a perfect square in here, then you can just stop right there. Yes. Now, if this happens, though, 4 plus or minus the square root of 16 divided by 2, I don't want you to leave it like that. What is the square root of 16? 4. So this problem I'd want you to work out. You'd have to do 4 plus 4 divided by 2, which is 8 divided by 2 is 4. And then you'd also have to do 4 minus 4 divided by 2, which is what? 0. So you might get some problems that are just like last night's, where you can keep going. Okay, now, here is what's new today. Alright, guys, let's focus on today, okay? And then I'll go over those questions when we grade homework. But yes, we did do some of those. That's why you need to go back and watch the video. Alright, I want to talk to you about 2 other cases. All of the problems that you have been dealing with so far did this. The problems you did last night were some kind of parabola that crossed the x-axis twice. If you look just at the radical part, now keep in mind, tonight for homework, you're doing the whole entire equation. I am just showing you what happens when you look just at the radical part, which this is the part we have to simplify first anyway. If this ends up being a number that's bigger than 0, if you're inside your radical, inside your square root is a positive number. That's what bigger than 0 means. That's the case where you have two roots. Now, they might not be nice whole number roots, but you will have two roots anytime this number in here is positive, whether it's a nice perfect square or whether it's something like the one we just looked at, the square root of 20. Does that make sense? That is not the only type of parabola that you could encounter. You sometimes are going to get a parabola that never crosses the x-axis at all. Now, if you are simplifying, and this is going to happen on several problems tonight, if you're simplifying your quadratic formula and what's inside your radical symbol ends up being less than 0, what kind of numbers are less than 0? That would be a negative number. Think about that for a second. Like, let's say it's simplified down to the square root of negative 16. What's the square root of negative 16? Alright, so negative 4 times negative 4 equals negative 16. Okay, so positive 4 times positive 4 equals negative 16. Yeah, it has to be the same. So guess what? Watch what happens when I try to get the calculator to tell me the square root of negative 16. It says error, non-real, quit. So what does that mean? It means that there are no roots. Now, that would be a picture that looks like something like this. Or this, where it never crosses the x-axis. Now, I don't want you to tell me no solution, because I need you to understand parabolas, no matter what they look like, have millions of solutions, always. However, sometimes a parabola will never actually cross the x-axis. That means the output will never be a 0. That's these kinds of parabolas. And how can I tell that? First of all, I wouldn't be able to factor it. Second of all, if I tried to use the quadratic formula, I would end up with a negative number under here. So as soon as I see that, you're going to tell me no roots. You're not going to tell me no solution. You're just going to tell me it does not have roots. Alright, and then there is one other case, folks. And yes, you should be writing this down. If the radical symbol, when you simplify it, once you do the b squared minus 4ac underneath the radical symbol, if it actually equals 0, then what happens in that case is you just have one root. And that does happen sometimes. And you would just tell me what that one root is. That means it's a parabola where the vertex is actually the same as the root, where it's only touching the x-axis one time. But every parabola will do one of these three things. Every parabola in the world will either cross the x-axis twice, and you'd get a positive number in here. It might cross the x-axis once, and you'd actually get 0 in here. Or it might never cross the x-axis, and you'd get a negative number in there. Yes, you are going to need to know this for your CBA. You're going to need to know it for your homework tonight. Yes. Okay, we'll talk about that next time. Let's focus on learning today's lesson. Okay, so tonight, let's talk about let's do some examples real quick of what you could expect to see. Again, we are going to be practicing with the quadratic formula. You might have 2 or 3 that could be factored, but I don't want you to factor. I want you to use the quadratic formula. For example, look at number 1. X squared minus 2x minus 7 equals 0. If I wanted you to factor this, guess what? You can't. Why can't you factor this? Okay, well, let's just try to. What are the factors of 7? What are the only 2 factors of 7? 1 and 7. Will they ever add up to a 2? So guess what? You cannot factor this. Does that mean it doesn't have roots? Not necessarily. Just because you can't factor it doesn't mean it doesn't have roots. I don't know if it's got roots yet. I'm going to now move on to a different way to find roots, which is the quadratic formula. A is 1, B is -2, and C is -7. Alright, so plug all that into the quadratic formula. Yeah, the more you use it, it's going to get burned into your brain. Okay, so the first part is the opposite of b. Well, if b is -2, then the opposite of b is +2. Okay, and then -2 squared is 4. Please be careful inside the radical symbol. I would always look at these last three numbers, the -4 times a times c. Count up your negatives, and that'll tell you if you're going to put a giant plus or a giant minus. I've got a -4 and a -7, so that's going to become a giant plus. So this is 4 plus Alicia phone up here. This would become 4 plus what? 28. What is 4 plus 28? 32. So this is now 2 plus or minus the square root of 32 divided by 2. Can I keep going? No. I mean, if you had a calculator, you could. Does this have roots? Yes. How many? Chris, how many roots does this have, people? We just talked about it. Is 32 positive? Yes. How many roots does it have? 2. What are they? Well, I really don't know. This is the best I can put right now because you don't have a calculator. If I gave you a calculator, then you'd have to punch it in and get an estimate. Alright, let's look at this thing. Which we're getting closer and closer to calculator time. Y equals x squared minus 2x minus 7. If I look at a picture of it, it definitely has 2 roots because this was a positive number. Are they 2 nice whole number roots? No, they're going to be somewhere around 4-ish and somewhere around -2-ish. But you couldn't give me an estimate unless I gave you a calculator. So in that problem, we're done. This is your set of 2 answers. You can stop right there. Are you good with that? All right, let's look at another one, number 2. Y equals -x squared minus 7x plus 3. Y equals -x squared minus 7x plus 3. Now, we're not trying to factor, and you couldn't factor this. The factors of 3 are never going to add up to a 7 in the middle. This kind of parabola, I can tell this is going to open down. How can I tell it's going to open down? Because it's got a negative value for a. But I don't know if it has roots yet. I can't factor it, but I can try to do the quadratic formula. What is a? -1. What is b? -7. What is c? 3. Plug those in and let's figure out what we get here. Did this one have roots? It should. I got a positive number inside the radical symbol. What's 49 plus 12? Now, is 61 a perfect square? No, but does that mean it doesn't have roots? It has 2 roots. I know it has 2 roots because this is positive. I said if it's negative, it doesn't have any roots. Then it has no roots. If this was a negative number, it would have no roots. Okay, now, so for the roots, you can just leave the answer like this, because you don't have a calculator. If I gave you a calculator, you would have to actually kind of get the calculator to estimate the square root of 61, and then you'd have to work that out. But since 61 is not a perfect square, we can leave our 2 answers just like this. I don't know. Let's focus on what we're doing today, folks. Number 3. Y equals negative x squared plus 4x minus 7. That's a function notation. What are we going to let y, what do we want y to equal in this problem? 0. We're trying to find the zeros. Plug everything you know into quadratic formula. What happened on this one? You should have gotten a negative number inside the radical symbol. You should have gotten negative 12 inside the radical symbol. Now, what does it mean if I've got a negative number in this radical symbol? So what are you going to put for your answer for this one? You're going to put no roots. Now please listen carefully. The answer to this problem is no roots. I will only give you credit, though, if you show me that you tried to use quadratic formula and then you realize, uh-oh, I can't take the square root of negative 12. So you're not going to get credit for the answer if you don't have work, and the work better be the quadratic formula. Nicole, did you not get negative 12 in there? Okay, inside the radical symbol, it's b squared, which 4 squared is 16, minus 4 times negative 1 times negative 7. Now please be very, very careful. Look at the back end of this problem. It's a negative, and a negative. What kind of number is that going to be? It's going to be a giant negative. So this is 16 minus 28. Well, a positive 16 and a negative 28 make a negative 12. And that's when I realized, hey, that's never going to cross the x-axis then, because you cannot find the square root of a negative number. All right, number 4. Y equals x squared minus 6x plus 9. And we are trying to find the zeros, so we're going to set this function equal to 0 and see if it ever crosses the x-axis, and if it does, we're going to write where it crosses the x-axis. Try this one, please. What happened on this one? The number inside the radical symbol is what? 0. Can you take the square root of 0? Absolutely you can. What number times itself is 0? Every single number times itself is 0. So 4 times 4 is 0. 8 times 8 is 0. 0 times 0 is 0. What does it mean if you get a 0 inside the radical symbol? There's only one root. Okay, that's just for your information. That's we're going to get the same answer twice. You still have to answer it. This ends up being 6 plus or minus the square root of 0, which guess what the square root of 0 is? 0 over 2. Well, what's 6 plus 0? 6. What's 6 over 2? 3. What's 6 minus 0? Also 6. What's 6 divided by 2? 3. So in that case, you would just put one answer because there is only one answer. It's 3. One root, and you would tell me what it is. You don't have to tell me it's one root. I can tell it's one root because you're just going to put one answer. Does that make sense? Okay, so real quickly, let's just review. I want to show you the different possible ways your answer might look. Let's say I had -2 plus or minus the square root of 25 divided by 2. Can you keep going on that? Absolutely, because what is the square root of 25? 5. So I better see -2 plus 5 over 2, which is 3/2, and I better see -2 minus 5 over 2, which is -7/2. That's how you would write an answer for that kind of problem. What if you had 4 plus or minus the square root of 18 divided by 6? What do you do there? Stop. This is the answer. Why can't I keep going? Because 18 is not a perfect square. Does it mean that it doesn't have roots? It absolutely has roots. What does it tell me about the roots? Yeah, they're not nice roots. They're weird decimals or fractions. So we're just going to stop right there. You also might get something like this. 6 plus or minus the square root of 0 over 2. Can you keep going? Absolutely. How many roots are you going to get there? Just one, because the square root of 0 is 0. So you would get 6 over 2, and then you'd also get another 6 over 2. So you don't have to write the answer twice. The answer would just be 3. And then this might also happen. Let's say you had something like this. -5 plus or minus the square root of -20 divided by -4. So what would you tell me there? Here's where you would tell me no roots. How can I tell this isn't going to have roots? Yeah, you can't take the square root of something negative. So those are the 4 possibilities that are going to happen to you on your homework. Your homework is I'm only giving you 8 problems. Page 444, 1 through 8, using the quadratic formula. And if you get a perfect square, you better keep going. If you get a number that's not a perfect square, you can just leave your answer in that form. If you get a number that's negative inside the radical symbol, you would tell me there are no roots. Oh, I'm sorry, 444. Page 444, 1 through 8. Now, please look at page 444. You want to look at the questions that are underneath the words written exercises. There's 6 questions kind of at the top. You're not doing those. And you ignore the directions. The directions say something about draw the graph and find the turning point. The directions say on all of it to determine the turning point. We're not talking about turning point. We're talking about roots. So don't pay attention to the written directions. Pay attention to Miss Himes' directions. You're doing 1 through 10 underneath written exercises, and you're finding the roots using quadratic formula. Those are the directions. That's 8 questions. 1 through 8. Did I say 1 through 10? I'm sorry. 1 through 8. 1 through 8. 1 through 8.